As a kid, did you play adventure games from companies like Sierra Online and LucasArts? Games like King's Quest or Monkey Island? Or if you're a bit older, you may have been into text-only adventure games from Infocom like Zork or Hitchhiker's Guide to the Galaxy. Or perhaps instead you're into Dungeons and Dragons. What all of these games have in common is that natural language is a primary game mechanic. And I think natural language is an incredibly powerful game mechanic because it allows the player to interact with the world in near infinite ways, in theory at least. However, the adventure game genre, which I see as the genre where language plays the biggest role, has really become a niche after dominating the game industry in the late 80s to mid 90s. And other game genres like role-playing games, RPGs, they may have a lot of language, you may have lots of dialogue with NPCs, non-playable characters, but I don't think you can really say that natural language is the primary game mechanic. But what if we were to revisit the adventure game genre in the mid to late 2020s in this age of exciting generative AI? Could our powerful large language models, speech recognition and synthesis, and agentic harnesses be a core component of a game's mechanics? This is the question that I'm going to try and answer in this series of GameDev vlogs. And the first step, we'll build a proof of concept voice agent that can run locally in Unity. You can speak to the agent, literally speak, not just type, and it thinks, plans, remembers, and does other agent stuff, replying to you in a natural feeling real-time latency. All the core library code and models we'll be using are open source with a permissive commercial use license. So all of what I'll be discussing here is feasible for use in an actual commercial game. If you want to try out the voice agent that we'll be developing in this vlog series, you can do so simply by installing a Unity package that I've created and uploaded to GitHub and opening the included sample scene. The package is called Voice Agents for Unity, no stars for creativity, but hopefully a star from you. It would really mean a lot to me. Go to the link, install it, try it out, and give it a star on GitHub. I've got the link in the video description below. Hello, Pipecat, are you there? Okay, can you play any games? Let's play 20 questions. Yes, it's something you can hold in your hand. It is something man-made? Yes, it does have buttons. You guessed it. No, actually, I don't really like that game. So how did we get to this point? Well, when doing a project like this, I think the first thing is always don't reinvent the wheel. See what others have built and what we can reuse and adapt. Now we'll look at the prior work more generally in terms of how have LLMs, speech recognition and speech synthesis been used in video games up until this point in time. We'll do a survey of that in a future video, but let's have a look at how voice agents, what the options are for voice agents in Unity and other game engines. So there's the whisper.unity package. Now this is just speech to text and it isn't so flexible. We're going to want to swap out the model, and we'll also want to run the model in a process outside of Unity, which this package doesn't do. There's another library called Unity Neurospeech that has all three components, speech to text, LLMs, and text to speech, but it's really reinventing the wheel, implementing parts of the real-time voice pipeline from scratch. We want a solution that's flexible and modular so we can take advantage of the latest developments in generative AI models and tooling. We also want to make use of pre-existing libraries as much as possible and not have to be responsible for maintaining a voice AI pipeline, i.e. so push as much of that outside of our code as possible. Well, there's the perfect library for that, and it's called Pipecat. Pipecat is used throughout the voice AI industry, it's open source, and in my opinion is excellently designed. So let's go with that. I'll explain some more of the details of how exactly it works later on, but all we need to know for now is that it is a pipeline orchestrator for voice agents. So let's work out a plan. Our starting point is not knowing anything at all about Pipecat or the particular protocols and systems that it uses to communicate. And the end goal is to have a working voice agent for Unity. I think it helps to break things down into really incremental steps and work on one thing at a time. And a good starting point is from something that we know to work already. So my first milestone was to get Pipecat running a real-time agent on my MacBook using a repo provided by the main Pipecat maintainer. There's a few extra steps though. We have to provide an open AI compatible inference server. Fortunately, again, an incredible dev has already solved this problem with a version of VLM for Mac Silicon called VLM-MLX. So it doesn't matter what model we start with. In this case, we'll launch it with a quantized version of Llama 3. Let's get that going. Now we can start both the example Pipecat server as well as the client that comes with this repo. It has a really nice interface and is written in JavaScript and React. So let's check it out. Okay, so we were able to get the example Pipecat voice agent for Mac working, but the client was written in React and is accessed via a web browser. And so I'm no full stack developer, so it's kind of hard for me to decipher. There are so many layers of indirection, which makes it difficult to work out exactly what code is getting called where to establish the connection to the Pipecat server and stream the microphone input to it. So how about we try and develop a simplified vanilla JavaScript version? And after some trial and error, making use of the Pipecat docs and the code for the React client, I hacked together this minimal JavaScript. Fantastic, we're making some progress. Now, this next step probably isn't necessary, but I think it's helpful to have a Python client so we can run and debug everything within Python if we need to. So I took my vanilla JavaScript client that was boiled down to its essential components and wrote a version for Python, making use of a library for Python that enables WebRTC communication, which is the protocol that Pipecat uses. So from our vanilla JavaScript and Python clients, we've been able to establish the basic ingredients needed to make a working client. So it should follow across pretty straightforward to C# and Unity, right? Well, for the most part, we have a few choices for the library to use for WebRTC. And I'm going to go with Unity's own library, unity.webrtc, because it's easy to get started with and it follows very similar idioms to the JavaScript and Python APIs for WebRTC. I also found another library from Unity built on top of WebRTC called render streaming, and it's designed for video and audio multicasting for online multiplayer games, i.e. streaming from humans to humans, whereas we just want an audio stream to another process on the same machine. So local human to bot. Still, I found it had useful code to create a streamable media track from the microphone, which we could then pass to unity.webrtc. So taking and adapting a bit of code from render streaming, as well as some Python code from our Python client, I was able to cobble together a proof of concept. It's not pretty, has quite a few limitations, which I'll discuss shortly, but still, it's a working voice agent running from play mode in Unity, and it satisfies our requirements of being modular and flexible. So I think that's a pretty good place to finish my episode 1 of this voice agents vlog. We've got a basic proof of concept that we can start iterating upon. Now to discuss the limitations, which are many and quite serious. Hopefully I'll be able to solve those in the following videos. Firstly, speech to text is not streaming and inference is slow. So we have to wait for the entire sequence to be transcribed, which can take between a third to 3/4 of a second using the Whisper Large Turbo model. So the solution might be to write a new service to run a different model that's much faster locally. But this isn't essential for a proof of concept. So let's optimize that later. We can sort of consider it as game polish. Secondly, there's no text to speech yet. This is good to have, but not essential. So again, we'll chalk that down to future game polish. Now this one, the third one, is a bit more serious. The player has no signal to know when the agent is active, so they don't know when they can start talking. I think for this, it would be really cool to have some sort of like an indicator, like maybe like an ear icon that is showing on part of the screen, like an overlay to indicate that the agent is ready for input. Another limitation is that we have to reconnect to the Pipecat voice agent client every time we enter play mode. And this just doesn't seem so practical because when we're developing, we want to like iterate quickly. So we want to be able to enter play mode and exit play mode really, really quickly and not have to wait. It's like 5 to 10 seconds. So can we launch this from the editor and have it already running before the developer enters play mode? Let's have a look into that in the next video. Another quite serious limitation is that if the voice agent is disconnected, there's no way to reconnect to it other than restarting play mode. So we need to be able to control this within play mode. So maybe the voice agent's running in the background. It doesn't start taking input until you press maybe like the space button, but we need to be able to operate the voice agent with a lot more control within play mode. Finally, all of the values, all of the settings are hard-coded into the code. So for example, which microphone it's using, the audio device, and several other things. And so we would like to be able to control these via both the editor, maybe like in one of the like inspector panels, as well as during the game mode itself. So maybe like you pull up like an overhead display and you can change the settings there. We need to implement something like this. So we've got our work cut out for us. You can see that there's many serious limitations, but this is like a proof of concept, so that's okay. And this is like a good foundation for us to start iterating and improving upon. And if there's any other limitations that you noticed or things that could be addressed that I haven't addressed, then please don't hesitate to leave a comment below. So I hope you enjoyed the first episode of Let's Build a Game with a Voice Agent. I'll try and come up with a catchier title in the following videos. In the next 2 episodes, I'll do a survey of how large language models, speech to text and text to speech have been used in computer games already. So we'll look at like what are those games? How were they used? Was it fun? We'll also continue working on the Unity for Voice Agents package. So if this sounds like it's something of interest to you, don't forget to like and smash the subscribe button. And my promise is that I'll make some really cool content over the following months. But until then, thanks for watching and happy vibe coding. May the vibes be with you.